In this tutorial, we're going to take a look at the reparamatization tools in Grasshopper to affect a bunch of curved triangles to create this pattern that you see on the screen. And then at the end of the tutorial, we're going to apply this pattern to a mesh that we created in a previous tutorial. So you'll see on my screen that I've got open a Grasshopper document, which is an example file that you can download from the different design if you're a member. And this basically just has the mesh that we used in the previous tutorial. We're not going to use this straight away, but we're going to use it later on once we've created the pattern that we're after. So first, I just want to talk about what reparamatization is in Grasshopper. So let's start just by, in Rhino, just creating a line over here. It can be any kind of line, it doesn't matter. And I'm going to preview that mesh over. We'll use it later, so don't delete it out of your file. I'm going to create a curve and just reference that curve right in there. So reparamatization is essentially a process where we squish down what's called the domain of this curve. So we've learned about domains in the previous tutorial. It's essentially a set of values that lie between two numbers, and those two numbers are what make up the domain. So I'm going to use something called the evaluate curve component, and you can find this under curve. I'm pretty sure it's under analysis. It's there, evaluate curve, and I'm going to plug that into curve. We're going to evaluate the curve at a certain parameter, which is a number, and I just want to find out, what the length of this curve that we've drawn is. Mine is 55 in length. I'm in millimeters, so that's my units, but that doesn't really matter. And I'll just, go and make a number slider that's at 50 and plug that into parameter. So evaluate curve essentially creates a point along a curve that you've plugged in at a given parameter. So in this case, the parameter is becoming the length of the curve. So if I was at 0, it would be at the starting point where the length of the curve is 0. And if I keep going up, I'll eventually get to the end of the curve and I can go past it and I'll get thrown an error. And this error tells me that my parameter is outside the curve domain. Now we know that the curve domain ends at its length of 55 and the results may be unpredictable. So they can be very unpredictable when you have something that's maybe a polyline or a curve with actual curvature in it. This is obviously a straight line that we've created for our curve. We can actually go through a process called reparamatization, which is going to help us when we have multiple curves. So you can see if I go and create another curve and it's a bit smaller than that one, I could then go and reference both of these guys in, set multiple curves like that. And basically I'm being thrown like an error on, this output saying that, the parameter is outside the curve domain, the results might be unpredictable. Say, for example, if we wanted to find the midpoint of both of these curves, I could go ahead and just right click on this curve here and use the reparamatize command there. And what that does is it squishes the domain of these curves down so that this starting point is the value of 0 and this starting point is the value of 1. So if I go and create a number slider that's a value of 1.000 and I plug that into parameter, I get the end point of both of these curves. If I make it 0, I get the start point of both of these curves. If I make it 0.5, I get the midpoint of all of these curves. So reparamatization essentially gives us power over multiple curves to find a self-similar point on each of those curves. So we're going to use this logic to create the pattern that you saw at the start of the tutorial. I'm just going to run through what we're going to do in Rhino so you can get a fair idea of it. And we're going to create a polygon first just in Rhino. That's just a triangle, so 3 sides. And essentially what we'll do is in Grasshopper, we're going to write a little algorithm that takes this polygon, it explodes the polygon into 3 separate lines. And then we're going to reparameterize each of those lines and evaluate the curve at, say, like a value of 0.2 on each of those. So you get 3 points like that. And then we're going to find the opposite point on the opposite end of the curve. If this evaluation is 0.2, the opposite would be a 0.8. And we'd find that on all those points there. And then the last thing we're going to do is we're going to create 3 extra points that move these edges inwards towards the center face. So there'd be like a point there, a point there, and a point there. And then we're going to create a polyline through each of those points, just like that. Oops. And we're going to do all this in Grasshopper. So essentially what you'll be able to do is you'll have multiple curves. So if we went and mirrored this, you would start to get an interesting pattern that looks something like this, that had these kind of like perforated star geometries coming through, like that, and like that, and like that. And we're going to go and recreate that logic inside of Grasshopper. So I'm going to go and delete this stuff, and we're going to start with a triangular grid. So you can find that under the vector tab under grids. I'm going to go to triangular, and I'm going to start with a triangular size of maybe 12, just so it's a little bit bigger and we can see it. I'm going to actually just start with 1. I'm going to make my slider between 0 and maybe like 20. But I'm going to make the number slider worth a value of 1, and I'm going to plug that into the x of y, just so we can get an understanding from one triangle how this is all working. So the first thing we've got coming out of here, out of this triangular grid, is a polyline curve, which makes this triangle up. We're going to start by exploding this triangle. So that's under the curve output. I think it's under analysis, but I can't remember. It might actually be under utilities. Yeah, there it is, explode, under utilities. So I'm going to go and plug that cell into curve, and it's going to go basically and explode my curve into 3 segments. I could go and get list item out of that, and you'll see it's, creating little segments of these things. Then, just what we did in Rhino, I'm going to go and evaluate that curve. I'm going to reparamatize it. Oops, not simplify, reparamatize. And I'm going to make the parameter 0.20. I'm going to make a copy of that, because then we want to evaluate it at 0.8 in this situation. So let's create, to make it parametric, a subtraction tool like that. Oops, sorry. I'm going to plug that into B, and we're going to go 1 subtract 0.2. like that, and we could go and slide that around, and we're getting this kind of mirrored output here. So I'll make that 0.2 again, and straight away we've created 2/3 of the points that we want to create. So the last points that we wanted to create, as we mentioned before, was we want to move these kind of edge points inwards to create like a third group of points that help us create that little star pattern in the triangle. So to do this, I'll move all this stuff across, and I might move this back a bit, and then I'm going to find the end points of these segments, not because I want the end points, I actually want the start points in this instance. I'm then going to find the area of these cells, because I want the midpoint of each of those cells, so the area component will give me that centroid point there of this cell. And then I'm going to draw a line in between the start point and this centroid there, like that. Cool. Then I'm going to go ahead and evaluate the curve. In fact, I'm going to evaluate at 0.2 like that one. Plug that guy into there, and then we're getting that third little point there coming through. So I might go and preview a few of these guys off. So we've got those points that we've got going on here. Now, the issue we have here is that we have these points in 3 different lists, and they're all in order. So I can't just go and plug these points into here, these points in here, these points in here, and then create a polyline. It'll create a mess, as you'll see in a second. Total mess. That's not what we want. We want to basically weave these things together. It's the opposite of a dispatch or a cull pattern that we've used before. We're going to take 1 point from this group, then 1 point from this group, then 1 point from this group. So I'm going to go and use the weave component. And we're going to basically, like I said, it's the opposite of the cull pattern. You input a pattern. Our pattern, because we've got 3 inputs, is going to be 0, 1, 2. And I'll plug that into there, and I'm getting a red error because I need to make this a multi-line data component, and I'm going to zoom in and make that stream 2 appear. The order that I want to put these in is I'm going to go with this point here, which is that kind of moved in point that we've got there. Then I'm going to grab our top point and our second point, and that will basically go and weave that list together in an order that we're going to be more happy with. And hopefully if I create my polyline, I've created a nice little kind of face, essentially, that is essentially just moving those points around based on that original triangle. I'm going to invert that, so I have a closed polyline. Then we'll probably have an issue here if I go to 2 or maybe 4, because we've got a data structure problem going on that we need to resolve now. So to resolve this data structure issue, I'm going to flatten all the cells coming out of this triangular grid, because we don't need them in the order that it's kind of creating. It's going to cause us headaches later. And then the thing that we lastly need to change is, you'll notice down here at this line, we have a mismatch in our data structure. So I'm just going to go and graft that centroid up there so that those data structures align, and you'll see we're able to get this pattern that we're after coming through as our output. So I'll preview all this stuff off, and we start to get that star-like pattern appearing in our geometry. So I could go and increase the number slider of this, and we get quite a few of these. So hopefully you've still got your mesh up here. It's quite easy, in fact really easy for us to go ahead and apply this to the mesh. The components that we need is we need a triangulate mesh component. The reason for this is if I created some face boundaries right now, you'll see straight away that all of the faces on this mesh are quads, and we're dealing with triangles in our algorithm. So we're going to go and triangulate that mesh, and you'll see straight away the faces change into this triangular pattern here. We can use those face boundaries now to input into our little algorithm. So I'm just going to go and make sure that's flattened first. Yeah, it's looking good. I'm going to go and basically grab these with a shift control and then click and then plug them into boundaries. And this will take like a couple of seconds to load because it's quite a few faces to go and compute, and suddenly we're getting that mesh pattern appearing that triangular pattern appearing on our mesh. Now the last thing we want to do, because obviously this is just a bunch of polylines now, is we want to go and turn that into actual physical geometry. So I'll go and mesh all of that, and this will take a couple of seconds to load, but once it's done, it'll essentially go through and create a mesh of each of those polylines. And as you can see straight away, we've gone and created that, star-like geometry through our mesh itself.